As we saw in the last video, we love telling stories to explain the data we observe in the world. But does that mean we take all available data into account, or that we place the same weight on all the data we do consider? No way. As it turns out, our judgment can be swayed surprisingly easily, even if the data don't change at all. We call this effect framing. How we frame the data matters a lot. Let's see an example where these details matter. All applicants to a job in your firm were asked to supply a recommendation. Each recommender was instructed to supply 6 adjectives in no particular order that describe the applicant. The applicant that you're currently reviewing was described in the following way: intelligent, industrious, impulsive, critical, stubborn, envious. So on a scale of 1 to 10, 1 indicating do not hire and 10 indicating hire immediately, how would you rank this applicant? Before we dig into the details, take some time coming up with a character in your mind that fits these characteristics. What type of person is he or she? How do these traits all fit together? Alright, so hopefully you have a character in mind. Notice that the prompt explicitly says that the order of the traits does not matter. We weren't asked to rank the traits in order of their strength, for instance. Now imagine we were to present the same prompt, only with the words reversed. Envious, stubborn, critical, impulsive, industrious, intelligent. Again, before we dig into the details, take some time coming up with a character in your mind that fits these characteristics. So, which person would you rank more highly? If you're like most people, you would think the first person is better for the job. People who see words like envious and stubborn first will respond significantly worse to the candidate than those who see the words in the opposite order. But how can this be? The words are exactly the same. Both the first and the second candidate are intelligent and stubborn, industrious and critical. So what's the deal? Even if we don't realize it, we're constructing a story about the job applicant in our mind. In the first case, we might place less positive traits, like impulsive and critical, in the context of traits which we've already accepted, like intelligent and industrious. For instance, we might picture a very smart but not very patient person who pursues her ideas passionately, even to the point of impulsivity, and is critical of others' perhaps less well thought out ideas. A very coherent picture, right? In the second case, we do exactly the opposite. We place words like industrious, intelligent in the context of things we have already accepted, like impulsive and critical. We might picture someone who, though they're smart, bounces around from idea to idea, never really getting anything much accomplished, while at the same time shooting down other ideas that might be more attainable. Our feelings about a particular topic can also be influenced by whether the statement is phrased in terms of positives or negatives. For example, considering the following two statements. A, the probability of surviving a medical procedure is 90%. B, the probability of dying from a medical procedure is 10%. People who see B typically think the procedure is more important than people who see A. But the outcomes are exactly the same, so how can this be? Well, as we'll see in more detail, we think fundamentally different about gains and losses. Phrasing the question in terms of survival puts us in a success-oriented mindset. Phrasing the question in terms of dying puts us in a failure-oriented mindset. We're also susceptible to errors in quantitative reasoning when considering figures presented in percent versus absolute count. Take the following example. Mr. Jones is currently in a psychiatric hospital due to his history of violence. You are trying to decide whether or not he should be released. A. Patients similar to Mr. Jones are estimated to have a 10% probability of committing an act of violence against others during the first several months of after discharge. Or B. Of every 100 patients similar to Mr. Jones, 10 are estimated to commit an act of violence against others during the first several months after discharge. So, should Mr. Jones be released? Respondents either see version A or version B, but not both. Take a second to think about which of these ways of presenting the data would lead to a higher chance of Mr. Jones being released. Alright, first, notice that both A and B are in phrase of bad outcomes, so the positive versus negative phrasing issue that we saw earlier is not in play here. Given what we know so far about how we tell stories, do you think people that see version A are more likely to release Mr. Jones or version B? Well, people presented with version A, which presents the data in terms of probabilities, tend to think Mr. Jones is less dangerous than people who see version B, which presents the data in terms of counts. Version B invites you to think of 10 acts of violence. This is very specific. Version A only cites 10%, a precise but distant feeling figure. In all of these examples, we can feel very differently about the same data, just based on the way it is presented. How data is ordered, how it's placed in context, and how it is summarized can all lead us to very different conclusions. It's not very comforting to admit that we can be manipulated so easily, but this is what research has shown again and again. In order to make good quantitative decisions, we often need to distance ourselves from the problem at hand, at least a little bit, and analytic tools provide one way of doing this.